This is section 6.1, perpendicular and angle bisectors. In this video, we're going to focus on the angle bisector theorem and its converse. We begin by reading the theorem. If a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. Everything following the word if is the hypothesis. That's what we want to check if it's true or false. And everything following the word then is the conclusion. That is the result we expect if the hypothesis is true. So, reading the hypothesis again, a point lies on the bisector of the angle. Well, we see we have an angle bisector because these two angles are marked as congruent. With those angles congruent, we can say that ray AD bisects angle BAC. And I go back and I read the hypothesis again, and I see the focus is on a point, and we say, yes, we have a point D that lies on the angle bisector. Now that we have a true hypothesis, we have a point that lies on an angle bisector, we know the conclusion is true. So it is refers to the point is equidistant from the two sides of the angle. So D is equidistant to AB and AC. Those are the sides of the angle. If we go back to point D, we see this segment with a right angle, and whenever you have a perpendicular segment, that represents distance. So we know that these two segments are going to be congruent because equidistant means they're going to be the same distance, and that allows us to make this connection that they're congruent. So now that we know the angle bisector theorem, we can use it, and it says find the measure of AB. Well, AB is this segment here. We see that it is perpendicular to the side of an angle. We also notice that B is a point on the angle bisector because we have these congruent marks here. If those two angles are equal, then BD is an angle bisector. So the measure of AB is equal to 12 centimeters. They ask us to justify the answer. We can say because point B lies on the angle bisector, and is therefore equidistant from the sides of the angle. And we use this long explanation because we're learning this for the first time. But as we become more comfortable with what the angle bisector theorem means, we can write this answer much more succinctly by saying AB is equal to 12 centimeters by the angle bisector theorem. So this is the concise way to answer, and if you answer with a justification saying by the angle bisector theorem, it is implied that you understand that all of this is intended. And now we can apply the angle bisector theorem with an algebraic problem. We can say, well, we know that these two segments are congruent because these two angles are congruent, making QS an angle bisector and S equidistant from the sides. So we can write our equation 5x equals 6x minus 5 by the angle bisector theorem. And then we can solve. X equals 5. We go back and read the problem and see that it's not asking for X, it's asking for RS. And since RS is equal to 6x minus 5 and x equals 5, the measure of RS can be calculated by plugging 5 in for x, and we see that it is 25. So here's the converse of the angle bisector theorem. A converse just switches the conclusion with the hypothesis. So instead of starting with an angle bisector, we're starting with a point that is equidistant from the sides of the angle. And if we have that hypothesis true, we can conclude that the point lies on the angle bisector of the angle. So now we see that this is what is first given, and our conclusion should be to mark these angles congruent. And that's what this text below the theorem is stating. Since we have perpendicular segments that represent distance and they're both congruent, we can conclude point D is on the angle bisector, which means we can assume that these two angles are congruent. So if we look at this, we have the congruent distances. We need to see perpendicular, that's necessary, and congruent, and we say great, that means point K is on the angle bisector, which means that this angle here must be 37 degrees. So we can say the measure of angle JLK equals 37 degrees by the converse of the angle bisector theorem. That is the succinct way to answer it, or if you want a more thorough way of answering it, we can say the measure of angle JLK is 37 degrees because point K is equidistant from the sides of angle JLM making KL an angle bisector. Again, our goal is to be able to write our answers this way, but we want to make sure we understand that all of this is implied. So now we see that we have JK and KM are congruent with the congruent marks. They represent distance because they're perpendicular. So we can say JK is equal to KM. And that information is given. We didn't have to use any analysis or logic. The tick marks are there. That's given. So we can write 5x minus 12 is equal to 2y plus 6. And what we see is we have two different variables. Two variables means we need two equations if we're going to solve it. So we're going to need a system of equations. That means we need to write another equation that comes from this image. Well, because K lies on the angle bisector, we can say that KLM is congruent to JLK. And we say, well, why are we allowed to write this? The top one was given, but this one wasn't given. We put the congruent marks in there. Why were we allowed to do that? And you say, by the converse of the angle bisector theorem. So now we can take the equations or the expressions. So now we can take the expressions for angle JLK and MLK and set them equal. And if we take these two equations together, so I rearranged this top one to be 5x minus 18 equals 2y. I simply subtracted the 6 from both sides. And this bottom one, I notice if I subtract y from both sides, I get a 2y. And then I'll subtract 2 from both sides and get 3x minus 2. And notice that both equations are equal to 2y. So if all of this is 2y, I can plug it into the other 2y using substitution. And we can solve for x. Now that we have x is 8, we can plug that back into one of our equations here. 3 times 8 minus 2 equals 2y. That gives us 22 equals 2y. And we see that 11 is equal to y. So we solved for x and y. We used the given information. We used the converse of the angle bisector theorem. And now we can take those values for x and y and we can solve for each of the measures if we wanted. jk, when you plug in 8 for x, would give you 28. km, when you plug in y with 11, when you plug in 11 for y, gives you 2 times 11 is 22 plus 6 is 28. They are equal. We expected that because of the congruent marks, and we set up our equation that way. And now we can check out our angle measures as well. 3 times 8 is 24, plus 11 is 35 degrees. And angle MLK, 3 times 11 is 33, plus 2 is 35 degrees. And we see that the angle measures are equal, which we expected from our converse theorem. Because all of these are in agreement, we should feel confident that we did this work correctly. So that's the end of this lecture. Go back, watch it again, take notes, pause it where you need to, and then complete the assignment.